Okay, the next topic is hybridization. Very important 3-mark question. What is hybridization? Hybridization is the intermixing of various orbitals having same energy, same shape and symmetrical orientation in space. Okay. Same that means what different orbital mean? S orbital, P orbital or sp and d and likewise because these are different orbitals, no? So intermixing of various orbitals. Now s and p combine together form sp orbital or s1 p2 mean sp2 orbital or sp3 sp3d sp3d likewise. So what is in hybridization? Intermixing of various orbitals having same energy and the same shape, the symmetrical orientation in space. That is called hybridization. Okay. Then now the salient features regarding hybridization, that is a 5-mark question. Salient features regarding hybridization. That means the orbitals involved in the hybridization should be same energy, and the shape also very same. Which orbital going to involve in hybridization, that must be same shape. So energy same arkano, then shape same arkano. Then the number of hybrid orbitals formed is equal to the number of atomic orbitals. Then what the orbital is taking part bond formation at least contain one electron. Okay, which orbital going to involve hybridization, it contain at least one electron, then only hybridization takes place very easily. During that time, the head-to-head overlap takes place mean very strong bond, sigma bond will form. Suppose during that time sideways overlap mean the pi bond will come. So that what is hybridization? Hybridization mean in the intermixing of various orbitals having same energy, same shape and symmetrical orientation in space. So the which one orbital undergoing under this one hybridization mean it must be same energy, same shape. That particular orbital contain at least one electron in it. Then only hybridization takes place. During that time, head-to-head overlap mean that's a strong bond, sigma bond will form. Sideways overlap mean its bond, pi bond will form. That is one important 5-mark question. Salient features regarding hybridization. Now we will discuss how to find hybridization. They will give any compound. They will ask which hybridization takes place. This question maybe we can expect in 1-mark part, sometimes 3-mark part also. Okay. First we will discuss one example for beryllium chloride molecule. Beryllium chloride. First you have to know, as a higher secondary student, you have to know at least first 30 elements, atomic number thoroughly. You have to know atomic number. Then only you can calculate valence electron. Okay, if you want to find valence, this one hybridization, you have to know valence electron also. So basically, one small rule is there. That means what? The finally the coordinates number will come. That number 2 mean, so maybe it becomes 2 or 3 or 4 or 5, 6. The coordinates number 2 mean which hybridization? Only 2-letter hybridization, sp. 3 mean sp2 because s 1 letter, p2 altogether 3. 4 mean what? sp3. S 1 letter, p3 letter altogether 4. 5 mean what? sp4. Is possible to 4? No. Because for p orbital maximum split into 3 types only, x, y, z. sp3, d. 6 mean sp3, d2. It's a common. Okay. Okay. Now, one small rule is there. That means when you are counting the valence electron, it's coming 8 or less than 8 mean divided by 2. One quotient will come now, that is this number, coordination number. Suppose that number 9 to 56 mean divided by 8. That time any remainders coming mean remainder by 2. That's the rule. Okay, first we will discuss for beryllium chloride. For beryllium, atomic number is 4. So what is valence electron? First 2 electrons enters in K shell. Second 2 electrons only in this second cell, last cell nothing but valence shell. So what is, how many valence electrons present in beryllium? You have 2 electrons. For chlorine, atomic number 17. So first 2, 8, 7. One chlorine contains 7 electrons. How many chlorines here? 2 chlorine. So 2 chlorine mean what? 2 into 7. How much? Altogether 16. 16 means come under which rule? 16 is here. So 16 by 8. What is the number? Quotient is 2. 2 means hybridization. So this is sp hybridization. Beryllium chloride is sp hybridization. Okay, we'll discuss one more example for BF3. Now boron atomic number 5. 5 mean valence electron 2, 3. So 3 electrons. For fluorine atomic number 9. So valence electron 7, 2, 7. How many fluorine? 3 fluorine. So 7 and 3. 7 and 3. How much? 21. Altogether 24. 24 means very same rule. 24 by 8. What's the number? 3. 3 means hybridization. sp2 hybridization. So your BF3 molecule is which hybridization? sp2 hybridization. Okay, very same thing. The next one is what? Ammonia. Ammonia mean what? What's the formula for ammonia? NH3. 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 First nitrogen atom. Atomic number of nitrogen is 7. So what is how many valence electrons present it? 2, 5. So you have 5 electrons. Then hydrogen. Atomic number is 1. So for one hydrogen, valence electron also 1. How many hydrogen present here? 3 hydrogen. So that 3 into 1 is equal to 3. Altogether 8. This will come under which rule? 8 here only. So 8 by 2 is equal to 4. 4 mean which one? sp3 hybridization. sp3 hybridization. It's very easiest one. So the next one is NO2 minus ion. NO2 minus ion. How to find hybridization? For usually nitrogen, atomic number 7, so valence electron 5, 2, 5. Oxygen, atomic number 8, so 2, 6. 1 oxygen, 6 electrons, 2 oxygen, so 2 into 6, 12. What about minus? These are what? These are electrons, valence electrons. This also symbol of electron only. How many minus? 1 minus. So you have to add one more. So altogether how much? 18. So 18 means this will come under which category? 18. Not here, so come under here. So 18 by 8. So when you are going to divide it, okay, 2 8s are 16. So first quotient 2. First remainder is equal to 2. 2 8s are 16, remaining 2. If you have any remainder as per rule, remainder by 2. So the 2 by 2 is equal to 1. So the second quotient is equal to 1. What about your coordinates number 3? Now you have to see 3 mean this is sp2 hybridization. Okay, clear? So minus means you have to add one more number. Okay, the next one is CO3 2 minus. What? CO3 2 minus carbonate ion. Now what? C mean atomic number 6. Valence electron 2, 4. So 4. Now oxygen is only atomic number is 8. So 2, 6. Okay, 1 oxygen means 6 electrons. How many oxygens present here? 3. So how what to do? 3 into 6. 3 into 6. How many electrons? 18 electrons. 2 minus. So you have to add 2. You have to add 2. Altogether 24. So as per rule, 24 is coming here. So 24 by 8. As per your rule, quotient is 3. So coordinate number 3 mean which hybridization? sp2 hybridization. So CO3 2 minus is 3 mean sp2 hybridization. The 2 minus. Okay. Next one is we will see in plus. Plus mean ammonium NH4 plus. NH4 plus ion. NH4 plus. First nitrogen atomic number 7, valence electron 2, 4. So valence electrons is 4. Then hydrogen atomic number 1, valence electron also 1, but 1 hydrogen, 1 electron. Here 4 hydrogens present, so that 4 into 1 is equal to 4. Hello. Nitrogen atomic number 2, atomic number 7, valence electron 4 or 5? 5. First electron 2 electrons, second electrons, first cell 2 electrons, second cell 5. Okay. Plus, when plus will come? When you remove one electron, it will come positive. So that become 9 as 9, 5 plus 4, 9, minus 1, only plus will come. It's equal to what? 8. As per our rule, 8 means coming where? Here. 8 by 2. 4 2s are 8. So quotient 4 means which hybridization? Yes, P 3 hybridization. So NH4 plus mean sp3 hybridization. So small thing, plus mean you have to minus 1 electron, minus mean you have to add 1 electron. 2 minus mean you have to add 2 more electrons, plus 2. Okay. Then one more easiest example, but common one is very big compound. The finding way is very easy. Xenon XeO4. Xenon means inert gas. So all inert gas contain 8 electrons in the outermost cell. So that they are very stable one. Okay, xenon mean inert gas, so that 8 oxygen, 8 valence electron, 6 fluorine, 9 valence electron, 7 1 fluorine, it contains 7 electrons, 4 fluorine, so 4 into 7, 4 7s are 28, altogether 22, remaining to 42. So now 42 mean, this come under which rule? Only this rule. Okay. So 42 by 8. This is not dividing. So that first quotient is equal to what? 5. Remainder 2. Any remainder mean that by 2 is equal to 1. So second quotient is equal to 1 is equal to 6. 6 mean which hybridization? sp2 hybridization, sp3d2 hybridization. So that sp3d2 hybridization. So if you have to find this hybridization, first you have to memorize 1 to 30 atomic numbers very clearly. Okay, then only you can find easily valence electrons. Then for like this, all the halogens, not only this one, all the halogens, it contains 7 electrons in the outermost cell. All the halogens mean what? Fluorine, chlorine, bromine, iodine. Astatine present in the 17th group, but that's not a halogen. Only these 4 things, only halogen. So these all fluorine, chlorine, bromine, iodine, valence electron 7. Like inert gases, all inert gas in what? Helium, neon, argon, krypton, xenon, radon. All inert gases except helium, because it's doublet. Because atomic number itself only 2. So it contains only 2 electrons. So except helium, all inert gases like helium, neon, argon, krypton, xenon, radon, all inert gases contain 8 electrons in their outermost shell. So don't worry, if you see any inert gas except helium, it contains 8 electrons in their outermost shell. Halogens mean 7. Okay. So how to find hybridization? Hybridization means intermixing of various orbital having same energy, same shape, symmetrical orientation in space. First you have to know the atomic number, then valence electron. You are going to count all the valence electron, That valence electron will come under 8 or less than 8 mean by 2. Then you have to see the quotient. See here. Suppose that is 2 mean sp hybridization, 3 mean sp2, 4 mean sp3, 5 mean sp3d, 6 mean sp3d2. Okay, this is the handy way to hybridization. Okay, the next topic is intermolecular forces. The important one is, first one is hydrogen bonding. Hydrogen bonding. What is hydrogen bonding? Hydrogen atom is bonded with one heteronuclear atom or highly electronegative atom like oxygen or nitrogen or fluorine. This is known as hydrogen bonding. Hydrogen bonding is always represented by a dotted line. That is hydrogen bonding. So hydrogen bonding means hydrogen bonded with one heteronuclear atom. That means one high electronegative element like nitrogen, oxygen, fluorine. Okay. Now one 3-mark question, very important 3-mark question. What are the conditions for effective hydrogen bonding? Which atom is going to combine with hydrogen that must be small in size? Another condition, the atom must be high electronegativity. So what are the two conditions for effective hydrogen bonding mean? One is the atom must be small in size, the atom must be high electronegative. These two are the conditions for effective hydrogen bonding. Now types. Types mean hydrogen bonding is very broadly divided into two types. One is intermolecular hydrogen bonding. Intermolecular hydrogen bonding. Another one is intramolecular hydrogen bonding. Okay. One is intermolecular, intramolecular hydrogen bonding. What do you mean inter? What do you mean intra? Any idea? What do you mean intermolecular hydrogen bonding? That means one is hydrogen bonding between within the molecule, one is hydrogen between two different molecules. What do you mean intermolecular hydrogen bonding? Inter mean what? What do you mean? What's the difference between inter-school competition and intra-school competition? Any idea? What do you mean inter? Inter mean hydrogen bond between two different molecules. Just think about international. Not only our nation, all nations together. So intermolecular mean inter-school competition or international. So intermolecular hydrogen bond mean hydrogen bond between two different molecules. Two different molecules. That mean what? Intermolecular hydrogen bonding. Intra-school competition within our school. So hydrogen bond within one molecule mean that is example for what? Intramolecular hydrogen bonding. First we will discuss about intermolecular hydrogen bonding. Okay. Intermolecular hydrogen bonding. Intermolecular hydrogen bonding. What? Hydrogen bond between two different molecules. Okay. See here, hydrogen fluoride, HF. This is one molecule. This is hydrogen fluoride, another molecule. This is hydrogen fluoride, another molecule. This is one school. This is also school, but another school. This is also school, but some other school. Now, competition between these two schools. Competition between these two molecules. Here is hydrogen bond. Hydrogen bond always represented by dotted line. Hydrogen bond is always represented by dotted line. It is hydrogen bond. Okay. Very same thing in the book is given somewhat stylish manner. HF. This is HF. This is another HF. This is another HF. Three different types of hydrogen bond, HF molecule. Now hydrogen bond is different. What? This hydrogen and this fluorine. This is hydrogen bond. Okay. Hydrogen bond between two different molecules, HF. Likewise, you can draw for ammonia or water molecule also. Water mean what? Water mean what's the formula? H2O. What? HOH. This is one of the water. Another water, HOH. Likewise. Now, where is hydrogen bond between hydrogen? This oxygen. But in the book is given somewhat different manner. Water, HO. This is one water. HO. Another water. HO. Another water molecule. Now, hydrogen bond between O and H. Here. Likewise. These are what? Hydrogen bond. Okay. Actually, when a hydrogen bond will form, no, H O H. Here, this is what? Del plus this del 2 minus. What is the difference between plus minus and del plus and del minus? Plus minus means fully ionized, fully positive, fully negative. Del plus means partially positive. Del minus means partially negative. 2 plus is there, so that 2 minus. That is a hydrogen molecule. This is water molecule. That is example of what? Intermolecular hydrogen bonding. Okay. Then one more is what? Intramolecular hydrogen bond. Now inter is over. So inter means hydrogen between hydrogen bonding between two different molecules. That means intermolecular hydrogen bonding. Like you are going to conduct sports competition between two different schools. Now next one is what? Intra. Now intramolecular hydrogen bonding. Hydrogen bonding within the molecule. Within the molecule. Okay. Now what? What is this? It's not a benzene. What is this? Cyclohexane. Now this is benzene. What is this? Hydroxybenzene. Nothing but phenol. In ortho position, I am going to draw one more group. That is what? Nitro group. NO2. So what's the compound name? Ortho nitrophenol. This compound name is what? Ortho nitrophenol is one compound. This is one compound. Here, hydrogen bond between this hydrogen and this oxygen. Hydrogen bond within the one molecule. Hydrogen bond is there. Where? Within the one molecule. So this is example of intramolecular hydrogen bonding. One more example. Okay. This is phenol. This is a phenol. Now phenol contains in the ortho position one carboxylic acid group. This is named as orthohydroxybenzoic acid. Orthohydroxybenzoic acid. Nothing but salicylic acid. Nothing but salicylic acid. Not cyclic. Salicylic acid. Okay. Here hydrogen bond between this H, this O. Hydrogen bond, it's a one compound. Hydrogen bond is where? Within the molecule. So this is example of intramolecular hydrogen bonding. One more example. Here, so phenol. Here is aldehyde. CHO, aldehyde group. Nothing but orthohydroxybenzaldehyde. Nothing but salicylaldehyde. Salicylaldehyde. So salicylaldehyde. Where is hydrogen bond? Hydrogen bond between within the molecule, this H and O. So these are the examples of intramolecular hydrogen bonding. So intermolecular hydrogen bond mean hydrogen bond between two different molecules. Intramolecular mean hydrogen bond between within the molecule. Example: orthonitrophenol, salicylic acid, and salicylaldehyde. Frequently asking one more question. Give one example of intramolecular hydrogen bonding. There are O-nitrophenol. O mean orthonitrophenol. Orthonitrophenol. Okay. The next one is importance of hydrogen bonding. Importance of hydrogen bonding also they can ask in 5 mark question. What is the importance? Why water is liquid state? Because of hydrogen bonding. Because of intermolecular hydrogen bonding only, water exists in liquid state. Okay. Altogether condense, finally water liquid in state. So why liquid state? We can't imagine our life, human life without liquid water. Because you can't live without water. Why? How this water became? Water is because of intermolecular hydrogen bonding only water became a liquid state. Okay. So very important is water. Or the next important water, we can imagine our all the clothes, all the materials made up of hydrogen bonding only. Then all the furniture items everything made up of hydrogen bond only. then our food items, carbohydrate, proteins, all those things made up of hydrogen bond only. First one thing what? Water, then food items, then our furnitures, then our cloth, then our skin also, skin, bones, all those things made up of hydrogen bond only. Only easy you can memorize 5 points. One is what? Water, then food items, furniture, our dress, then our skin, bone, all those things. Only 5 points. What are the importance of hydrogen bond? First, we can't imagine our life, human life, without water, because water is due to intermolecular hydrogen bond only. Water is lying between. Water is what? In liquid state. So first one is water. The next one is what? Food items. That mean our carbohydrate, protein, all are made up of hydrogen bond only. Then what? Our furnitures. Why there's a very strength mean? Because of hydrogen bond only. Then our dress, cotton, everything made up of hydrogen bond only. Then our bone, skin, our body is made up of hydrogen bond only. The importance of hydrogen bonding. So this lesson is over. So for board exam, you know very well board exam 10 mark you can expect from this lesson. 2 1 mark question, 1 3 mark question, 1 5 mark question. And the 5 mark question maybe MO theory or MO diagram for oxygen molecule or nitrogen molecule, de Broglie's equation, Davison-Germos experiment, then salient features regarding hybridization and importance of hydrogen bonding. The 3 mark question, first 3 mark question, you can expect what is Heisenberg uncertainty principle, and second one is significance of negative electronic energy, third one is difference between particle and wave character, fourth one is what is defined hybridization, then what are the importance of hydrogen bonding, what are the importance of hydrogen bonding, then why helium does not exist, why helium does not exist, then define bond order. These are frequently asking questions. Okay. Then in 5 mark part they can ask a problem also. We will discuss problem in the next class.